Welcome to the Level 1 Quantitative Methods Summary video series. This video is a summary of the Quant reading on hypothesis testing. Okay, now here is another item that lots of people have issues with, hypothesis testing, and then how to figure out whether we are doing a one-tailed test or a two-tailed test. So I'll give you some real simple scenarios that will help you understand the concept. You believe that the average return on all Asian stocks was not 0%. So you go to all Asian stocks and pull a sample, and the sample mean is 1%. Your sample size is 36, and the standard deviation of the sample is 4. And you want to use a 5% significance level. The moment you have a belief which says not equal to, then it means that you are doing a two-tailed test. If you have a belief that a number is greater than something or less than something, then you do one-tailed. So we've established that a not equal to implies two-tailed. So what is the hypothesis? You set it up this way. The hypothesis is that the mean is 0, because the null hypothesis is what you want to reject. And then the alternate is that the mean is not equal to 0. Alright, the rule for setting up the hypothesis is that the equal to sign must be in the null hypothesis. Then next thing is you need to come up with a test stat. When you are doing a hypothesis test related to the mean of a population, then this is the formula, and this is a must-learn formula. It is one of the high probability items for your exam. So this is X bar. X bar is your sample mean. So you draw a sample and you take the mean of that sample, that's X bar. Minus mu naught is the hypothesized value, which is coming from here, so that's 0. And then Sx bar is the standard error. Okay, it is also the variance of the standard deviation of the sample mean. And what's the formula for Sx bar? This formula is S over root n. In this case, we are given the S, which is standard deviation of the sample, and we are given n. So what is the standard error? It is this. S is equal to 4 divided by root n is root of 36, which is 6. So 4 over 6 is our standard error. What is X bar minus 0? That's 1. So 1 over 4 over 6. This gives us a test stat of 1.5. So you set your hypothesis, item 1. You come up with a test stat, item 2. Then given a critical value, so this critical value comes based on the significance level. If you are doing a two-tailed test and the significance level is 5%, then the 5% is spread across the two tails. Let us say that based on this and this, the critical value is minus 1.96 and plus 1.96. Alright, then how do you decide whether to reject the null hypothesis or not? If the critical value is in this range, then you do not reject the null hypothesis. Had the critical value been higher than 2 or less than minus 2, then you would reject the null hypothesis. Okay, next we look at a one-tailed test. You believe that the average return in a given month was greater than 2%. So the moment you see this, you are doing a one-tailed test. And if you believe that the return is greater than 2%, then make this greater than sign, and this is pointing to the tail that you are interested in. Okay, so that's how you remember which tail. So greater than means that you are interested in the right tail. Sample mean is 6%, and the rest of the data, n is 36. Here now the standard error is given. So this is the hypothesis. Notice null is what you would like to reject, and it has the equal to sign. Alternate is that the mean is greater than 2. How do you come up with a test stat? It is the sample mean. So again, x bar minus the hypothesized over the standard error. X bar is 6. Hypothesized value is now 2. It's not 0. Divided by the standard error which is given. So here you don't need to do any further calculation. So you have 2.67. Can you reject the null hypothesis? Yeah. You can, because now the test stat is greater than the critical value. Had the test stat been in this range, then you would not have rejected the null. But here you can reject the null hypothesis. Another important concept is the p-value. And people get confused by this. At the very least, you need to understand how to use this, whether or not you fully understand it at this stage, but you need to know how to make this work on the exam. So remember this definition. P-value is the smallest level of significance at which the null hypothesis can be rejected. It is analogous to the test stat. So there is a very straightforward relationship between the test stat and the p-value. A high test stat means low p-value. So if you come up with a test stat that is, let's say, way out on the right, the p-value is that little bit of probability that is still left. So high test stat means low p-value, and a low test stat would mean a high p-value. Now, can you use the p-value to accept or reject the null hypothesis? Yes. If you have a significance level of 5% and the p-value for a given scenario is 3%, if the p-value is less than the significance, then you reject the null. If the p-value is greater than the significance, then you fail to reject the null. So just remember what is stated on this slide, and there's a very high chance that if you do get a question, you will be able to answer it. Alright, type 1 and type 2 errors, you need to memorize these. So if this represents the true situation, let's say the true situation is that the null hypothesis is true. In other words, in reality, the null should not be rejected. And then based on your test, you do not reject the null. Is that correct? Yes. But is it possible that the null is actually true, but you incorrectly rejected it? That's possible. This is called a type 1 error. So just say this loudly a few times to remember, because people have trouble remembering this. If H0 is actually true and you reject H0, that's type 1. So if H0 is true and you reject H0, that's type 1. What's the other situation? The other situation is that H0 is false. That means that you should reject, but you do not reject. That's a type 2 error. So say this a few times. Should reject, but do not reject. That's type 2. And when I say should reject, obviously we are talking about the null hypothesis. So in reality, the null hypothesis is false. You should be rejecting it, but you do not. That is a type 2 error. And the final point to remember from this slide is that the definition of the power of a test is that the power of a test is 1 minus the probability of a type 2 error. Okay, now we get into the domain where I'd say that strictly speaking, this material is part of the course and you need to know at least the basics, but if you do not remember all the detailed formulas, you can still pass. There is tests concerning a single mean, which we've talked about, so this is very important and you must know. The key point here was to remember the test stat. What was the test stat? The sample mean minus the hypothesized value divided by the standard error, which is S over root n. So this is a must remember formula. You might also have to deal with a test concerning differences between means, and very occasionally this can show up on your exam. So this is the test stat for a situation where you are testing concerning the differences between means. So you have two populations, and if you have a situation where the two populations have the same variance, then you use this formula. There might be a situation where you have two populations A and B where the variance is different. Then there is a slightly more complicated version of this formula which I haven't even shown over here, because to be very honest, I have never learnt it and that's not hurt me. Okay, so if you want to learn it, you can. Strictly speaking, that's the diligent thing to do, but only do it once you have learned the important points and once you have practiced at least 3,000 questions. So once you've done that, then you can go learn the complicated formulas. You can also have tests concerning mean differences. So you have two populations, or actually the classic scenario that I use in my regular lecture is that you want to evaluate whether the return on Ford Motor Company and General Motors is different. So for every month or every period, you look at the difference between Ford return and GM return. So that then becomes what you are evaluating, the difference. So that's what we are referring to here, tests concerning mean differences. So you come up with the mean difference denoted by D bar, and then there is a standard deviation. This is the test stat. And then once you have the test stat, then the procedure is similar to what we've talked about. You have a test stat, you compare with critical value, and then based on that comparison, you decide whether or not to reject the null hypothesis. Tests concerning variance. Now, I would suggest that at the very least you just learn what's on this slide. When you have a variance, there are two scenarios. Either you have a test concerning the variance of a given population. For example, you have the variance of returns in the, let's say German stock market, and you believe that the the variance is more than 14%, just as an example. So there you just have one population, one variance, and the test that you will do is called a chi-squared test. And these are some points related to the chi-squared test. You will have a hypothesis, null hypothesis, alternate hypothesis. This is what the chi-squared test stat looks like, and you will compare this with a critical value to determine whether or not to accept the null, whether or not to reject the null hypothesis. And then the other type of test related to a variance is the F test, where you are comparing variances. So remember this, chi-squared is where you just have one variance, and F test is where you have two variances, and just try to remember all these facts. So read this slide a few times to memorize the facts. After that, all out practice.